Hello everyone, good day. Today we will talk about the QGIS and discuss the following. First is the history of QGIS, including the people who first contributed to the application. Second, differentiate QGIS from ArcGIS based on their application in geosciences. Third is what is Python console. And lastly, explain the plugins, the core, and the external plugins. So, QGIS stands for Quantum GIS or Quantum Geographic Information System. So, it is a free and open source GIS software. It is an OSGeo project. It is packaged with a bunch of other open source libraries and tools. It is an alternative to ESRI and ArcGIS. So here is Gary Sherman. So Gary Sherman is the founder of QGIS. So while he was looking for a fast geographic data viewer that runs on Linux and supports a broad range of data sources, um, he came up with an idea of creating a free software or free GIS software. So back in 2002, most of the commercial software vendors in GIS domain sold their desktop products only for one operating system. So therefore, he decided to start a new software project. So in June 2002, QGIS was officially registered as a project on a SourceForge webpage. So, the first CVS check-in dates were from July 6, 2002. So, it became an incubator project of the open source Geospatial Foundation in 2007, and the version 1.0 was released in January 2009. So the main feature of QGIS was to map navigation, attribute table, vector symbolization, point symbols, labeling, map editing, projections, tree view legend, print composer, project file, raster pyramids or spatial index, and scale dependent rendering.
Before I proceed to my topic, allow me to explain what are QGIS and ArcGIS. So QGIS and ArcGIS are computer systems, both function as geographic information system or GIS software, allowing users to analyze, capture, store, and edit spatial information. They also display data related to position on Earth surfaces, in addition to composing and exporting graphical maps by relating similarly unrelated data. These softwares can help individuals and organizations better understand spatial patterns and relationships. In short, ArcGIS and QGIS are both used for mapping spatial data. Differentiate QGIS from ArcGIS based on their application in geoscience. In terms of cartographic capabilities, there are more native cartographic output options with ArcGIS, like Maplex labeling engine, which allows different data frames to be added and linked. ArcGIS also has a lot of advanced mapping functionalities, while in QGIS, different data frames can be linked. QGIS doesn't have advanced mapping functionalities as compared to ArcGIS. In terms of file format accessibility, QGIS supports all formats, which consist of more than 70 different formats. QGIS can read rasters including TIFF, JPG, ArcInfoGrids, DM, etc. for a total of more than 50 different formats. And vectors including SV shape files, ArcInfo binary coverage, MapInfo, ACTS, and etc. for a total of more than 20 different formats. One important feature is the capability of reading and writing geodatabase or PostGIS data, both local and remote. It can also read web services or WMS and WFS, standard OGC. This allows the user to bring on common ground a variety of different data, thus acting as a powerful integrator. On the other hand, ArcGIS has a limited vector format. In terms of spatial analysis, QGIS has less and limited capabilities, which only allows the user to analyze and understand what is going on in a given vector dataset. While ArcGIS contains more out-of-the-box spatial analytic capabilities such as hair shading to overlays or overlaying, map algebra, surface approximation, and network analysis. In terms of statistical analysis, it is only partially supported by QGIS. On the other hand, it is fully supported by ArcGIS. In terms of remote sensing, QGIS relies on the semi-automatic classification plugin. Although it's a bit of a hit and miss, its strength is in coarse resolution, imagery extraction, and classification, whereas ArcGIS provides mean segment shift. It's rough and objects are not always meaningful. Overall, ArcGIS has made large strides forward in remote sensing. One of the biggest improvements in ArcGIS is it provides interactivity, which gives the user a sneak preview and allows the user to tweak parameters before the user fully commit. The toolbars you see from the left and right are remote sensing tools used to produce X-ray vision. The QGIS semi-automatic classification plugin you see on the left part of the screen lets the user to perform image classification in a semi-automatic way. On the right part of the screen, you will see the image analysis toolbar from ArcGIS. This will instantly provide a remote sensing analyst with the necessary tools to create samples and perform unsupervised and supervised classification. In terms in control workflow, QGIS has graphical modeler, which is used to automate geoprocessing jobs. When you run it on the task as a scheduled model, you can sit at home and let the graphical modeler to do the task for you. On the other hand, ArcGIS has Model Builder. It has the same functionality as the QGIS graphical modeler, which is also used to automate geoprocessing jobs. In terms of print functionality, QGIS is a viable option to create cartographic masterpieces. QGIS mapping interface is called Print Composer. This Print Composer can create nice maps and atlases that can be printed or saved as PDF file, an image, or an SVG file. This is a powerful way to share geographical information produced with QGIS that can be included in reports or published. It acts almost like another application and it only falls short to the ArcGIS capabilities. While ArcGIS Layout View shows how to set up map templates and export map products, ArcGIS exports in various formats like PDF, JPG, SVG, AI, PNG, EPS, and EMF. The ArcGIS Layout View is practical. It has tools to pinpoint your labels, set up map books, and link data frames with easy extend rectangles. In terms of symbology, although QGIS is more or less preloaded, it has some really advanced symbology. User can create simple gradients with two or multiple colors. All different types linear, radial, conical, then save as a QGIS layer style file. On the other hand, ArcGIS is rich of preloaded, as well as focuses more into practicality and puts symbol on the hands of the cartographer. It is loaded with stunning symbology on startup. In terms of topology manipulation, topology editing is a strong point in ArcGIS. With a ton of options to fix editing errors, ArcGIS is known as a strong tool in expecting and resolving topology issues with automatic or manual fixes. It has a data reviewer, which is like having a topology checker on steroids. The system automates data quality control for high-quality data and error management. While QGIS is considered a weak tool when facing topology issues or errors, which may also require the user to manually input the rules. That's all for my topic. Thank you for listening.
So now, let's talk about the Python console. So, Python console is an interactive shell for the Python command execution. So, it also has a Python file editor that allows you to edit and save your Python scripts. So, how to open the Python console? So, to open the console, go to the plugins and look for the Python console, or you can also click the Control plus Alt plus P. The toolbar. Here are the toolbar for the Python console. First is the clear console. It is to wipe the output area. Next is the import class. It is for processing PyQt4 Qt-core or PyQt4 Qt-QI class. And next is the run command. It is available in the input area. It is also same as pressing enter. So here is the show editor. It toggles the code editor visibility. Next is the options and help. So the console. So the console main features are code completion, highlighting syntax and call tips for the following APIs: Python, PyQGIS, PyQt4, Qcentilia true, and OSGUG.OGR. So here are the main um, shortcuts for the following. Control Alt plus space is to view the auto completion list if enabled in the option. So you first enable the auto completion list in the option before using Control Alt space to for it to gana. So next is execute code snippets from the following input area by typing and pressing enter or run command. Next is execute code snippets from the output area using the enter selected from the contextual menu or pressing Ctrl plus E. You can also browse the command history from the input area using up and down arrow keys and execute the command you want. So you can also open or to view the command history by using Ctrl Shift space and double clicking a row will execute the command. So the command history dialog can also be accessed from the context menu or input area. Next is to save and clear the command history. The history will be saved into the file named like this. Okay. To open the QGIS API documentation, you can type this. And to open PyQGIS cookbook by typing this. So the code editor. So the code editor, or you can use the show editor button or the icon like this to enable the editor widget. It allows editing and saving Python files and offers advanced functionalities to manage your code. You can comment and uncomment code, check syntax, share the code via codepad.org, and much more. The main features are the code completion, highlighting syntax and call tips for the following APIs, the Python, the PyQGIS, PyQt4, QCentilia, OSGOGDAL, OGR. Here, um, you can use control space to view the auto completion list if enabled in the option also. The difference is the alt. So in console, you will use Control Alt space to view the auto completion list. However, in a code editor, you can use Control space. So you can also share code snippets via codepad. We also have here the Control plus 4. Um, it is to check the syntax. And next, we have also the search bar. The search bar is usually open with the default desktop environment shortcut, or you can also use the Ctrl plus F. So, use the default desktop environment shortcut to find next and previous, or you can also use Ctrl plus G and Shift Ctrl plus G. So, you can automatically find the first match when typing in the find box. So, yeah. Set the initial find string to the selection when opening the find. Then, pressing ESC closes the find bar. Then, Object Inspector. It is a class and function. It is a class and function browser. So, go to an object definition with a mouse click and from the object and mouse click from the object inspector. So you can also use interselected command in executing the code snippets. Then you can execute the whole script by using the run script command. It is this create a compiled file with the name with an extension name of .pyc. Options. It is accessible either from the console toolbar or the contextual menu of console output panel or code editor. This adds further setting to manage and control the Python console behavior. So we have here the auto completion. If check the code completion is if if check the code completion is enabled, you can get auto completion from current documents from installed APIs and both APIs and current documents. Auto completion threshold. It's sets the threshold to display the auto-completion list in charts type. So the automatic parenthesis insertion. If checked enables the auto closing for bracket is accessible. You have a auto closing for brackets. Next is the auto-saved script before. So it allows you, before running, it allows you to save automatically the script to be executed in order to avoid to save it after any modification. This action will store a temporary file into the temporary system directory that will automatically deleted after running. Using preloaded APIs file. So you can choose whether use the preload APIs file or load some APIs file saved on your system. Next is using prepared APIs. So APIs file. So if checked in asterisk.pap file will be used for code completion. To generate the prepared APIs file, you have to load at least an asterisk.api file and then compile it by clicking on the compile APIs button. So that could be all. Thank you.
Good day, everyone. I'll be tackling about plugins in Qgis software. Plugins in Qgis add useful features to your software. Plugins are written by Qgis developers and other independent users who want to extend the core functionality of the software. These plugins are made available in Qgis for all the users. These plugins can be developed in Python, which was already discussed by Mr. Cruz. It also can be developed in C++ programs plugins, which are typically implemented as shared libraries that are dynamically loaded and sometimes unloaded by the main program. But in our discussion, we are mainly focusing within Python-generated plugins, since it is by far more commonly used. Plugins can be quite small and large in size. For example, there's a plugin that would size about 20 megabytes and is virtually a complete program for data analysis of remote sensing data. Next, it is that QGIS plugins run within the QGIS system environment and allows interaction with the QGIS interface, since you can find the plugins easily within the interface. In every QGIS distribution, there is a plugin directory, and when QGIS is launched, plugins are loaded from the plugins directory. And when you start QGIS, the program checks this plugins directory and loads any plugin that it finds there. It's really that simple. You can also reload a plugin within a QGIS session by disabling it and then enabling it again, and we'll take advantage of this to streamline the development process. You can also add new plugins to your QGIS environment. Most users will not want to do this, so the better ways available is to download it as a zip file or send one of your plugins to someone else's send your plugin to someone else as a zip file, and then use the option in the QGIS plugin manager to add a plugin from a zip file. There is also an official QGIS plugins repository that you are probably familiar with that is connected by default, and this contains plugins that might be of general interest to all QGIS users. From what I understood, you can have a platform of interaction between plugins users, since you might want people to access your repository, or you might want to create your own repository for your organization if you end up developing a lot of custom plugins specific to your organization. That would be beneficial to your people. I personally haven't tried this, so I am unable to provide visual examples. Today, we will be discussing two types of plugins, the core and external plugins. First is the core plugins. These plugins are core to the integration of the app, meaning it's already installed for you. So basically, when we install Qgis on our computer or desktop, core plugins also comes with it. I'll be explaining how to locate one of the core plugins and how to use them. I'll specifically use Spatial Query for this as an example. The first procedure is to open our QGIS application. Look at the interface and find plugins, and then click on it to open the plugin manager dialog. Second, even if this is your first time using QGIS, you will see a lot of plugins listed under the installed tab. This is because they are core plugins and were installed during QGIS installation, which I already mentioned earlier. So as I have said, we'll be using spatial queries as an example today. So what are they? This type of plugin is core to many types of GIS analysis. Spatial queries allows you to select features in a layer by their spatial relationships, intersect, contain, touch, and etc. with features from another layer. A layer is usually the display of a single file. Layers are what you have created in the application or inside QGIS, and also you can easily manage or create them with the help of plugins. In QGIS, functionality is available via the select by location and extract by location processing tools. Third, let's enable our plugin. First, check on the checkbox next to Spatial Query plugin. This will help us enable the plugin so that we will be able to use it. One thing to note is that plugins have the ability to insert menu items at various locations and create new panels and toolbars. Sometimes it is difficult to know how to find the newly enabled tools. One clue is to look in the plugin description and you'll find the category vector that indicates that the plugin would be found under the vector menu once enabled. Now click close. Now that the spatial query plugin is enabled, go to the vector to use the functionality added by the plugin, and that's it. That is how to locate the spatial query plugin. This is a link on how to make use of spatial query plugins. And also there are a lot of tutorials in this website on how to make use of different plugins of different types. Also, these are the other core plugins available in our software. First is the Coordinate Capture plugin, TB Manager plugin, Qgis plugin, Geometry Checker plugin, Georeferencer plugin, Meta Search Catalog Client, Offline Editing plugin, and Topology Checker plugin. Now let's move into external plugins. External plugins are available in the QGIS plugins repository and need to be installed by the users before using them. An easy way to browse and install these plugins is by using the Plugin Manager tool. First thing in the procedure is the same as what we did when locating core plugins. Just click on Plugins and then click on Manage and Install Plugins to open Plugin Manager dialog. Second, to see the available plugins for installation, click on Get More tab. Here you will see a list of plugins listed. Next, for this, let's find and install a plugin called Contour plugin. As you're scrolling or just type Contour in the search box, you will see the search results below, and then click on the Contour plugin. Next, click on Install Plugin button to install it. Once the plugin is downloaded and installed, you will see a confirmation dialog. Or in other version of the app, it will just install automatically. If you noticed that there is no mention of the plugin category in the description, that makes it hard to determine how to access the newly installed plugin. Most external plugins are installed under the plugins menu itself in Qgis. Now click on plugins and then you will see the newly installed plugin, the Contour plugin. Usually external plugins also install a button in the plugins toolbar. You may also use that button to access the plugin. For other types of external plugins, there's actually a lot available if you would try to browse your plugins directory. These are the other types of plugins. First is the experimental plugins. These are plugins generally unsuitable for production use. These plugins are in early stages of development and should be considered incomplete or proof of concept tools. Qgis does not recommend installing these plugins unless you intend to use them for testing purposes. Second is the deprecated plugins. Deprecated plugins are generally unsuitable for production use also. These plugins are unmaintained and should be considered obsolete tools. Qgis does not recommend installing these plugins unless you still need it and there are no other alternatives available. I guess that's the end of our report.